Good morning everyone, this is Amit and today I am going to show you how to calculate the stroke length for a crank and slot tail quick return motion mechanism and how to draw it. So quick return motion mechanism is the inversion of crank and slider crank mechanisms. So here we are going to show you the basic mechanism. Here in the crank and slot tail mechanism, the crank rod is fixed just like here, and this is the OA is the crank rod, connecting rod, and OB is crank, which is here it is piston, and this AC is the slotted bar inside which the piston slides. So here this circle is the trajectory of the point B as the crank will rotate in the direction, and this will oscillate this slotted bar from C1 to C2. So from C1 to C2. So the stroke length. Now calculating the stroke length. Here first of all, I like to give some parameters. Here the angle B, this is the angle B, and this is the angle this is angle beta, and this is angle alpha. So now the beta is the cutting stroke angle, okay, and alpha is the return stroke angle, and alpha beta plus beta is equal to, as in here, is equal to 360 degree, and beta upon alpha is called quick return ratio M, and is always equal to greater than 1. Now the stroke length from here is our tool. The tool is moving from D1 to D2. So our stroke length is D1 D2, the distance. It is equal to C1 C2, and this is the center point of the C1 and C2. So it is equal to 2 C1 M. Now here D1 D2 equal to C1 C2 is equal to 2 C1 M. And from taking this triangle AOB1 here, AOB1, okay, here the angle between this and this angle is alpha by 2. So this angle is 90. So this angle will be 90 minus alpha by 2. So now taking the whole this triangle AC1M, we can calculate the C1, which is equal to AC1 sin 90 minus alpha by 2. AC1 sin 90 minus alpha by 2, which is equal to 2AC1 cos of alpha by 2. Now considering this triangle, only this triangle AOB1, we can calculate the cos of alpha by 2. From this triangle, the cos of alpha by 2 is equal to OB1 by OA. Look at it. Cos of alpha by 2 here. Cos of alpha by 2 from here will be this is B1 here. Now cos of alpha by 2 is equal to OB1 by OA, which is equal to OB by OA. This here OB1 is equal to OBB. It is the radius of the crank. So radius of this circle, and the length of the crank. Now we will put this equation here. Now putting cos alpha by 2 OB in equation 1, we will get stroke length is 2 AC OB OA. There AC is the length of the slotted bar, OA is the connecting rod length, and OB is the crank length, okay. Now it is also equal to 2 times length of slotted bar multiplied by length of the crank divided by length of connecting rod. As we can adjust, we have 3 parameters to adjust the stroke length. That's why this crank and slot tail quick return motion mechanism is used more as compared to the Whitworth quick return motion mechanism, which has only one variable to set the stroke length. Thank you.